In this video, we will factor trinomials. The technique that we're going to work with today is called sum and product method to factor our trinomials. To factor the trinomials in this form, ax squared plus bx plus c, we have a and b as numerical coefficients and c is a constant term. Sometimes a is going to be worth positive 1, and sometimes we'll have some other values there. In step 1, we're going to find two integers that have a product equal to a times c, so we'll be multiplying the coefficients a and c, and the sum comes from the value of b. It could be either positive or negative. We'll be replacing that bx term with two terms using the two new integers as coefficients, and then we'll factor the resulting four-term polynomial by grouping, just like we did in the last video. So here's our first example, x squared minus 3x minus 18. I've got a table all set up for the sum and the product. So our sum comes from this middle coefficient, negative 3, and the product, remember, comes from multiplying a times c. In this case, it's 1 multiplied by negative 18. So that would make a negative 18 for the product. What we're trying to do is come up with two factors of 18 such that when we multiply, we get negative 18. But if we add those numbers, we'll end up with a sum of negative 3. So just to start out with, you might think, well, 2 times 9 makes 18. We need to make negative 18. So either 2 would have to be negative or 9 would have to be negative. But keep in mind, when we're adding those numbers, we have to make something negative. So I would say that the larger number would be the negative. 2 times negative 9 does match negative 18. But if I add 2 with negative 9, that's going to make negative 7. That does not match the sum we need. So we need to try some other factors. So what else would make 18? Let's see. 3 times 6 makes 18. And if we use a negative 6, 3 times negative 6 will match negative 18. And then 3 added to negative 6 makes a sum of negative 3. Notice how that sum is a match for the sum we need, and our product is a match for the product we need. So what this tells us is the factors of positive 3 and negative 6 are going to replace the middle term in our original trinomial. So we really are going to work with x squared plus 3x minus 6x minus 18. So notice that I replaced the middle term with the factors from our table. Notice we have four terms. We're ready to group. So here are the two groups. Looking just at the first group, I can see that they both have x in common. And that leaves x plus 3. So what we learned about grouping is that our other quantities should also be x plus 3. So working backwards with distributing, x times how much would match negative 6x? It looks like negative 6 is needed. Is 3 times negative 6 a match for minus 18? It is. So our final factoring would be that common factor of x plus 3 multiplied by that other factor formed when I join x and negative 6. So x minus 6. Here is our factored answer. In the next example, we're starting with 2x squared minus 17x plus 21. So here's the strategy written again in case you need to check back. We're filling in a sum coming from minus 17. And the product is 2 times 21, and that would be positive 42. So a lot of us think of 6 times 7 as factors of 42. 6 plus 7 makes 13. So that's a little bit too small, and the sign isn't correct either. So one quick way to check the sign or fix it would be to make -6 times -7, and that also makes positive 42. But then when I add those negative numbers together, that fixes the sign to be a -13. So I'm a little bit closer to -17, but not quite there. So that means I need to choose some numbers that are a little farther apart. I see that it's an even number, so maybe -2 times negative something else would work. So 42 divided by 2 would be 21. Is -2 added to -21 going to help? That makes -23. So now that's a little bit too far. So maybe -3 times something would be helpful. 42 divided by 3 would make 14. Is -3 added to -14 a match for what we're looking for? And it is. That works. So I know to replace the middle term with -3x and -14x. So 2x squared minus 3x minus 14x plus 21. So we're ready to group. We have our 4 terms. In the first group, we have x in common with 2x minus 3 left over. That means our other quantity must have 2x minus 3 in common. So 2x times something needs to match -14x. That would be a -7. And check the last term. Is -3 times -7 a match for 21? That looks good. So we can see our common factor is the quantity of 2x minus 3. And the other factor is found by joining x with -7. So we have x minus 7 for that other factor. So we have now completely factored our polynomial. For example 3, we have 12x squared plus 10x minus 50. And did you notice that we should factor out a greatest common factor first? Because 12, 10, and 50 are all even numbers. That means they have at least 2 in common. So I'll start by factoring out 2. That leaves 6x squared plus 5x minus 25. So if I distribute 2, I can check to make sure this is correct. 2 times 6x squared matches 12x squared. 2 times 5x matches positive 10x. And last, 2 times -25 matches the -50. So this might be as far as we can go. We did factor using greatest common factor. But since we have this trinomial in the parenthesis, we might be able to factor a second time. So from the center here, this coefficient of +5 will tell us the sum we're looking for, +5, and 6 times -25 would give us the product. So I know that's going to be -150. Since it ends with a 0, 10 times something might be a good place to start. And don't worry if your first guess is not correct. It will help us to make a better guess the second try. So 10 times 15 would make 150. And one of these factors must be a negative number. If I choose 10 to be negative, then -10 plus 15 equals +5. Well, that works out. That's exactly what we want. So I know to replace the middle with -10x and +15x. So look what happens. I need to remember to keep 2 as the original common factor. 6x squared will not be changed, and -25 will not be changed. It's a new middle that we have. So right from the table, I'm going to start with -10x. Next, I'll include +15x. So notice we've included the variable that the original middle term had. I know whether to use plus or minus according to plus and minus used in our sum and product table. So you don't have to guess what to use. You'll already know. Notice we have 4 terms. That means we're using the grouping technique. So I create one group and a second group. Again, I'm keeping the original 2, that was our greatest common factor, because I don't want to forget to include that in the final answer. Now within my big parenthesis, I'm going to have a lot of parentheses here. I have a 6 and a 10, so I know 2 is the common factor there. And they both have x, so I better make some room to include the x. So it's really 2x that's in common. Now I'll use the distributive property to recreate those terms. 6x squared is what I need, and I'm starting with 2x. So it looks like 3x is needed, and then 2x times minus 5 would complete that quantity. So that tells me 3x minus 5 is needed for that second grouping. So 3x times something needs to match 15x. That would be positive 5. And make sure that negative 5 times positive 5 does match negative 25. So what we have here is the original 2 for common factor, our new greatest common factor of quantity 3x minus 5, and then that is going to be joined with 2x plus 5. So quantity 2x plus 5. And now we have our completely factored answer. So we'll try another one like that last one because it is a little more complicated. 18y cubed plus 6y squared plus 2y. So notice that 18, 6, and 2 are all divisible by at least 2. And we also have a variable in common for all terms. So we have at least y in common. So let's see what's left over. Using the distributive property, 2y times 9y squared. And then to make positive 6y squared, it looks like we need 3y. 2 times 3 makes 6. Y times y matches y squared. And the last term, it looks like 2y is exactly the same. Both are positive, so we need plus 1. So when we distribute, we will be able to create positive 2y. So again, we might be finished with our factoring. We did at least factor using a greatest common factor. But maybe this trinomial can be factored a second time. So in the middle, 3 is our sum, and 9 multiplied by 1 makes positive 9 for the product. So factors of 9 could be 1 times 9 or 3 times 3. But let's see if they have the correct sum. 1 plus 9 would match with 10. That's not going to work. 3 plus 3 makes 6. That doesn't match either. So the only other factors of 9 would involve negative 1 and negative 9, which adds to negative 10. That's not helpful. Negative 3 would match with negative 6. So it doesn't help to change the signs. There's nothing in the sum and product table that would help us to continue the factoring process. So we tried it, it doesn't work. So we know that what we had originally with a common factor of 2y is the most factoring that could be done for this polynomial. So 2y times the quantity of 9y squared plus 3y plus 1 is completely factored. In our last example, we have y squared plus 3y plus 4. So this time we don't have a numerical coefficient in common for all because remember this is 1y squared. 1, 3, and 4 only have 1 in common and that doesn't help. Only the first 2 terms have y, so there's no GCF. We go straight to sum and product. Our sum comes from the middle as positive 3. Product would be 1 times 4, so that makes 4. Factors of 4, 1 times 4, 2 times 2, And that's about it unless we include negatives. So let's start with positive 1 and positive 4. That matches with 5, so that is not going to make 3. 2 plus 2 makes 4, so that's not 3. So again, the only thing we could do to try to help us out here is to make negative 1 times negative 4. That just makes a negative 5. So that doesn't help. Negative 2 times negative 2 will make the positive 4 product. But when we add those, it becomes negative. So there isn't any way for us to create a sum of positive 3. But we also didn't factor using a common factor. We didn't factor at all. So this is called prime. That means it is not factorable at all using any of our factoring techniques.